So today let us discuss the topic hebb learning in artificial neural network. So the description is when an axon of cell A is near enough to excite cell B and repeatedly or permanently takes place in firing it, some growth process or metabolic change takes place in one or both the cells such that A's efficiency as one of the cells firing B is increased. According to Hebb rule, the weight vector is found to increase proportionately to the product of the input and the learning signal. In Hebb learning, two interconnected neurons are on simultaneously. The weight update in Hebb rule is given by Wi of new is equal to Wi of old plus Xi y. The Hebb rule is more suited for bipolar data than binary data. If binary data is used, then the above weight updation formula cannot distinguish two conditions, namely a training pair in which an input unit is on and target value is off, and a training pair in which both the input unit and the target value are off. Let us see the algorithm for Hebb learning. Step 0. Initialize all the weights Wi is equal to 0 where I is equal to 1 to n. Step 1. For each input training vector and target output pair, the input vector is specified as S and the target as T. It follows the steps from 2 to 4. Step 2. Set activation for input units, that is Xi is equal to Si, where Si is the training vector which is given as input to Xi, where I ranges from 1 to n. Set the activation function for output unit Y is equal to T. So the above steps complete the algorithm process. So when the output is not equal to the target output vector, then we have to adjust the weight and bias. So we have to update the weight and bias as Wi of new, that is weight of new is equal to weight of old plus xi into y, where xi is the input vector and y is the output vector. For I is equal to 1 to n, and we have to update the bias b. So new bias is equal to old bias plus y. So let us see the problem. Use Hebb rule. Find weight required to perform the following classifications of the given input pattern. Plus symbols represents the value 1 and empty squares indicate minus 1. Consider I belong to the member of class, so has target value 1, and 0 does not belong to the member of class, so the target value minus 1. So as per the problem given, we have two patterns known as I pattern and O pattern, and the plus symbol represents the value 1 and the empty represents minus 1. Similarly for O pattern also we have to specify. Here we have to specify the inputs as x1, x2, x3. So we can specify this as x1, x2, x3, x4, x5, x6, x7, x8 and x9. Similarly for the O pattern also we will be specifying it as x1, x2, x3, x4, x5, x6, x7, x8 and x9. See here, if it is of empty means then we have to specify it as minus 1, and if it is of plus symbol means then we have to specify it as 1. So now let us find the solution for this problem. See here the solution. First what we have to do, we have to specify the pattern. So what are the two patterns we have? I and O. See here the I pattern and O pattern. So we have I and O. Now what we have to specify is, we have to specify the input. So how many inputs we are having? X1 to X9 and the target value is Y. Okay, so as per here what we have x1, so if it is of plus means we have to write it as 1. So x1 we will be writing it as 1, for x2 1, x3 1 and x4 we don't have any value, so here it is of -1, and x5 1, x6 -1, and for x7 1, x8 1, and x9 1. So as specified, if it is of I pattern means then the target value is 1. Okay, so here the target value we have to specify is 1. Similarly for the O pattern we will be having. So O, see here, x1, x2, x3 we have plus, so we have to write it as 1. So x1 1, x2 1, x3 1, and for x4 will be having 1, and x5 will be having -1, x's will be having 1, x7 1, x8 1, and x9 1, and the target will be having it as -1. So here the target value is -1. Now we have to set the initialize weights to 0 and bias to 0. We have to set, and we have to initialize the weights to 0 and bias to 0. So W1, W2, W3, W4, W5, W6, 7, 8, 9. So all these are weights. So we have to initialize all the weights to 0. So here it will be of 0. So W1, W2, everything will be of 0. And similarly for bias also we have to set it as 0. So as per here, for simplicity and for easy of understanding, just we are initializing the weights to 0 and bias to 0. So the first case, what we have to do is, so presenting the first input pattern I and the target value. So what is the target value we will be having for the input pattern? That is 1. So what we have specified here, the target value is 1. Here we have specified it as 1. So we have to present the first input pattern I and the target value y is equal to 1. Now what we have to do, as per the hebb rule, we have to update our weight and the bias. So here wi of new is equal to wi of old plus xiy, and bias of new is equal to old bias plus y. So now let us calculate w1 of new. So w1 of new means w1 of old plus xiy. So already we are having wi as 0 because we have initialized all the weights as 0. So we will be having it as old weight, that is 0, plus your xi value. So what is the xi value? Here you are having x1, so that is of 1. So let us have it here. So it will be of 1, and the next one is we have to see the y value. So what is y? We have set the target as 1, so we will be having multiplied by 1. So what is the value we will be having? The value is 1. That is 1 into 1, 1 plus 0 will be having 1. Similarly for here we will be having w2 of new. So what is w2 of new will be having? So wi of old, so that is w2 of old. So w2 of old is 0, plus we will be having xi. So what is the value of xi we will be having? Here we will be having 1. So 1 into our target value will be having 1. So 1 into 1 will be having 1. 1 plus 0 will be having 1. So next what we have to calculate? w3 of new. So what is w3 of new? Again wi of old. So all the weights are initialized as 0. So 0 plus, and here we will be having the x3 value. So what is x3 we are having? 1. So 1 into your y value 1. So we will be having it as 1. Then next w4 of new. So what is w4? Here we will be having the old value as 0, plus here x4 is -1. So we will be having -1 into y value 1. So here -1 into 1, -1 plus 0 will be having -1. Similarly w5 of new. So w5 of new is equal to, will be having 0 plus xi value. So 5 means we will be having the value as 1. So 1 into 1 will be having. So here the value is 1. And next one is w6, 0 plus, we will be having an input x6 as -1. So -1 multiplied by 1 will be having -1. Similarly for w7 we will be having 0 plus, here the value is 1. So 1 into 1 will be having 1, and W8 of new, so 0 plus will be having 1 into 1 which is equal to 1, and W9 of new, so 0 plus 1 into 1 which is 1, and bias of new we have to update the old bias. So bias also we have initialized as 0, so 0 plus your y value. Here bias of old plus we are having it as y, so here will be having 0 plus 1, so the value will be 1. Okay, so now we have to update the new weights. So what are the new weights we'll be having here? 1 1 1 minus 1 1 minus 1 1 1 1 and 1. So these are all the new weights we'll be having. Okay, so next one is your case 2. So case 2, what we have to do is we have to present the first input pattern O, and the target value here it will be of y is equal to minus 1. Similarly, what we have to do, we have to update the weight and the bias. So now your weight of old, the old will be here, this new vector becomes now the old because we have come to a second case. So what happens here? Wi of old. So what is Wi of old? We are having 1 plus xi. Only for 5 we will be having minus 1. So here for 5 only we are having minus 1. The remaining all we are having 1, and the target is minus 1. So what happens here? Wi of old is equal to 1 plus the xi value is 1 into the target is minus 1. 1 into minus 1 minus 1. Minus 1 plus 1 will be having 0. So for W2 of new, what happens here? The weight is 1. See here, this weight we have to take. So W2 weight is 1. So 1 plus 1 into minus 1, again we'll be getting it as 0. So for W3 of new, 1 plus 1 into minus 1, again 0. For W4 of new, what we have? The weight is minus 1. So what happens here? Minus 1 plus, for 4 we will be having 1 into minus 1. So here what happens? Minus 1 into 1, minus 1, minus 1 and minus 1 we are having minus 2. Similarly, what we have to do is we have to update the weights for W5. So what is W5? So the old weight we should have. So what is the old weight of W5? See here, we will be having 1, 2, 3, 4, 5. So 5 will be having 1 plus, already we are having 5 into minus 1. So minus 1 into minus 1 plus 1. 1 plus 1 we will be having it as 2. Next for W6 of new. So what is W6 of new here? See here, 1, 2, 3, 4, 5, 6. So 6 is minus 1. Minus 1 plus 1 multiplied by minus 1. So what will have? Minus 1 will be having minus 2. Then W7 of new. So W7 of new we are having 1. 1 plus 1 into minus 1. So what happened here? 0. Similarly, W8 of new, 1 plus 1 into minus 1. Again 0. For W9 of new is also 1 into minus 1 will be having it as 0. So bias new. So what is bias new? Already we have here the bias as 1. So now this bias becomes the old bias, that is bias of new is equal to 1, and now this becomes the old bias. So here 1 we are having. So what happens? Bias of new is equal to bias of old plus y. So what happens here? 1 plus y value is minus 1. So automatically the bias becomes 0. Okay, now we have to write the final weights. So what are the final weights we are having? 0, 0, 0, minus 2. So let us write here 0, 0, 0, minus 2. And here we are having 2, minus 2, 0, 0, 0 and 0. So now we have to represent this in a hebb network. So totally how many nodes we are having? We are having 9 nodes, and it has been connected to your output y. Okay, so from x1 to y1, what is the weight we are having here? 0. Okay, and from x2 to y we are having the weight as 0. Similarly, we have to write all the weights. This is how we will be classifying the input pattern with the help of the hebb rule.